All right, guys, welcome back. Hopefully you had a nice 10-second break. Um, but yeah, let's jump straight back in. We have the arithmetic series. So now, oh, sorry, arithmetic series. And an arithmetic series is the sum of an arithmetic sequence. So we're gonna see some kind of spooky looking stuff right below this, but all you need to know is that we're taking an arithmetic sequence. That's all the stuff we've been doing so far of those like small equations. And this is just like a shortcut, a formula for us to add all those numbers up to whatever n we're at. So like n equals 10, whatever, up to that. The sum of the first n terms is Sn. All right. So honestly, all this stuff right here, this is the theorem, but I think it's actually a little confusing, and it'll definitely be a little confusing. It's more confusing that it's online. So we're actually gonna skip this. You're not going to see any like proof or whatever on the test, so don't worry about it. But what you do need to know is the formula. So the formula is right here. Sn, S sub n equals n over 2 times a1 plus an. We actually want to rewrite this a little bit. All we're going to do is we're going to do Sn equals n times a1 plus an all over 2. Okay, so it's the same thing. All I did was move this 2 to be below the A1 and the AN. It's just gonna clean some things up for us later, but that is all you need to know. Just these two formulas that are interchangeable. All right. So let's slide on over. We have the sum of finite arithmetic series. Arithmetic series, add the sequences together. That's all we're doing. I do not know why this is in such fancy text, but it's cute. So that's fine. Here is the kind of rewritten equation that we just did in the previous slide. But here's a question. Find the sum of the first 25 terms of the arithmetic series. Okay, so we're given the series right below up to that looks like the fourth term. We have 11 as the first term, 14, 17, and 20. What do I see here? What is the common difference happening between these? Plus 3, right? So my difference is going to be 3. My first term is what? 11. So I have the two important parts. I'm going to do an equals a1 plus n minus 1 times d. Like, we're good at this. We're really good at this now. A25 is equal to 11 plus 25 minus 1 times 3, which is our common difference. And then if we simplify this out, we will get A25. Oops, that's wrong. We're going to get A25 is equal to 83. So now my last step is going to be to use this information. Okay, let me just section this off a little bit. But now we want to utilize the arithmetic series that we just did. So we're going to have S of 25, right? So now we're using the equation of the series. S sub 25 is equal to 25 times 11 plus 83 over 2, right? We're going to multiply those out. You will get an answer of 25 times 47. And then this together will be 1,175. Okay, so that is the sum of this sequence right here. That is the sum of all of them all the way to the 25th term. Okay. Now, originally, right, we would have to do just one by one and then just add it all up. But this is a nice little shortcut. So let's have you guys try the next one. So go ahead and pause the video if you want to go and try it first. Okay. Now let's do it together, or just check your work right here. What is the difference that's happening here? This is not part of it. But the difference right here, right? I'm seeing a difference of, looks like 0.4, right? So 0.4 happening right here. And we're being asked to, oh, that's someone yelling in the background, but ignore him if you hear him. Difference, common difference is equal to 0.4, and my A1 is equal to 0.5. Okay, that's my first term. So now we're looking for A10. So I'm skipping a few steps here of writing the equation, but you guys should be good at it now. I'm going to fill all this in. This should give me an A10 of 4.1. And my final step will be to utilize the series equation. S of 10 equals 10 times 0.5 plus 4.1 divided by 2 times, oh, no, that's it. Plug that in your calculator, multiply it out. You will get an S10 of 23. Fantastic. Not too bad. Next one, find the sum of the first 100 positive odd integers. Okay, so when it says positive, this is telling us no zeros. Right? So A1 is equal to 1. D is equal to plus 2. Right? We start on 1, not on 0, because we need positive integers. And they have to be odd, so we're going to continue to add 2. It'll keep repeating. Now, what do we want? We want the 100th, right? We want n equals 100. So we'll do A100 equals 1 plus 100 minus 1 times 2 is equal to 199. All right. Now, last step, we have S of 100 is equal to 100 times 1 plus 199 over 2. You will get a final answer of 10,000. Awesome. All right, so this one's just a little interesting because in this first one we did right here, we were given a sequence, right? But in this second question, number 65, it's kind of like a word problem. So hopefully that didn't trip you guys up, but this is a great example of a tricky question. Let us move on right here, standardized test practice. So this might be something you might see on the SAT or maybe even on the test, cough, cough. But what is the sum of the arithmetic series below? We have sigma of I, index I, equals 1 to 20, and a 3 plus 5i. So my question here is, what is A1, right? A1 is 8, because when I plug in 1, I have 3 plus 5, which is 8. Now let's use our formula. We're being asked to find it at A20. So A20 equals 3 plus 5 times 20. And what would that be? 103, right? So now we have all the parts we need. We have A1, we have A20. Now we're going to utilize the series again, the series equation. So S20 equals 20 times 8 plus 103 over 2. Use your calculator, multiply it out. You will get 1,110. So you will answer circle C as your answer. Cool. Okay, so now we've been looking at, that was all like finite sequences and stuff, but now we're just gonna take a little breather and look at some infinite sequences. The sum of the first n terms of the sequence is called a finite series, or the partial sum. So that's what we just did. Partial sum, finite series of the sequence, right? We had an n, we had a stop, and that is finite, that is partial. The sum of all terms of the infinite sequence is an infinite series. It's honestly just self-explanatory. It's infinity. Sum of the first n terms of an arithmetic sequence. Okay, so find the sums. Assume that the terms, by the way, we're kind of done with the infinite stuff. Like, that was just a quick pit stop just to get it in your heads. But here's just a little bit more practice for us. Sum of the first n terms of an arithmetic sequence. All right, so let's do letter A. I have 9, 12, 15, all the way up to a huge number of 366. First inclination, always, right? We're detectives. What is happening here? I'm seeing a common difference of 3. What else do I know? I know that my A1 is 9. Cool. So I would have an equals 9 plus n minus 1 times 3. Okay. Next step, I'm going to want to figure out what this n is. Because right here, 366, huge number, but we don't know what the n is. So 366 equals 9 plus n minus 1 times 3. You will find that your n will equal 120. Okay, so that's good to know. Now my next step will be to utilize the sine function. So I have s of n is equal to 120, 9 plus, oh, earlier I said sine function, huh? Not sine, series function. 9 plus 366 divided by 2. Plug that all in, you will get your series to be 2,205. 20. Man, sorry, I'm just tripping. Okay, you will get your series to be 22,500. Cool. Okay, now let's try B. Here we have a sigma summation equation. So we're going to have, right, we need to find what it is at the value of the first one, of 1, and of the top, 149. So 4 times 1 minus 12. This is the iteration for 1. What are we going to get? We're going to get -8. And then for 149, huge number, 4 times 149 minus 12 is going to be 584. Cool. Oh, we are a little bit out of space, but let me just zoom in. We'll zoom in a lot. Switch my color so we don't get distracted. But series equation, S of n equals 149 times -8 plus 584 divided by 2. You will get an answer of 42,912. Cool. Not bad, right, guys? I know you're all nodding, saying, yes, Mr. O, this is great. I love this. But here is, I think, our last problem. Oh, yeah, I don't like this one. Skip it. But let's do this one real quick. This is a word problem, so go ahead and pause and try it on your own. All right. An object with negligible air resistance, which means none, is dropped from the Sears Tower in Chicago at a height of 1,454 feet. During the first second of fall, the object falls 16 feet. During the second, it falls 48 feet. During the third second, it falls 80. During the fourth, it falls 112. If this arithmetic pattern continues, how far will the object fall in 7 seconds? So, right, this is a great example of us using our series. We're going to figure out 7 seconds, that's our n, and then we're going to add it all up all the way to the 7. So let's get some facts down for ourselves. We're going to use x of 1, right? That's when it falls for 1 second, or the first second of fall. So x of 1, 16 feet. I'm just not going to do a label, but you all should put labels. X of 2 is 48. X of 3 is 80. X of 4 is 112. So this is all the information we're given. Okay, and we want to find X of 7. All right, so a little detective work. I realized that this is what? A difference of 32. All right, so what do we have? We have our A1, we have 32. So we are good to go to start creating our first sequence equation. Oops. A of n is equal to A of 1 plus n minus 1 times t. Okay. I'm going to just quickly replace these with x's, or with the x's that we've been using. So x of 7 is equal to 16. That's our A1, or our x1, plus n when it's 7 seconds. So 7 minus 1 times a common difference of 32. All right. You will get your 7, your x7 to equal 208 feet. Okay, so this is important for us to know, and also x1. Last step, super easy, super chill. I hope you guys had a good time today with these formulas. But here we go, our series equation. We have series 7 equals 7 times 16 plus 208 divided by 2. And then we will end, let me get rid of this. There we go. And then we will get an answer of an object falling from the Sears Tower. After 7 seconds, it will fall 784 feet. Whew. All right. That is the last of our stuff. I blew through this a little bit. But yeah, great job, everyone. I'm not there. I'm very sad. I miss you guys, but hopefully this was a chill lecture. If you're super confused, I am so sorry. But come to office hours and I will explain it in a much better way in person. But please now go work on your homework and don't be so loud for the sub, especially my class 3A. And I think that's it. I'll see you guys next week. Have a great weekend. Goodbye.